Hello everyone. Today we are going to solve physics past year question paper unit 1 mechanics and material, and paper code is this. In this paper you can use scientific calculator, you can read instructions, information and advice. The total mark for this paper is 80. So directly come on section A, answer all questions. For question 1 to 10 in section A, select one answer from A to D and put a cross in the box. If you change your mind, put a line in the box and then mark new answer with a cross. For example, let us see A, B, C and D, and first you think, let me erase this. Okay, first you think A as a correct answer and you mark like this, and later on you decided to change your answer A to C. So mark on A option like this and new answer like a new cross in front of in the box. Okay, so question number 1, a student walks for 6 seconds. Displacement time graph for the student is shown. Displacement versus time graph is given to us. Which row of the table shows final displacement and velocity of the student? Okay, what we need to calculate is final displacement and velocity of the student. So before first we have to calculate final displacement. Final displacement is calculated from 0, not to minus 1, not from minus 1. It is calculated from 0. So from 0 it is 2. So final displacement is 2 meter, and velocity is, as we know the formula, velocity is delta S upon delta T. So now we will consider the whole displacement change. So 2 minus of minus 1, 6 minus 0, so 3 by 6, from here we get 0.5 meter per second. So displacement is 2 meter and velocity is 0.5 meter per second. So from here we got A as a right answer. Come on to question number 2. Physical quantities may be vectors or scalar. Which row of table is correct? So first of all, we know force is vector, mass is a scalar, and acceleration is again a vector. Scalar, force is scalar? No. Mass is vector? No. Acceleration is scalar? No. Is scalar? No. It's a vector. Mass is a scalar? Yes, it's scalar. And acceleration is vector? Yes, this is right. But force is vector. Mass is vector? No, it's not. And acceleration is scalar? No, it's not. Force is vector? Yes. Mass is scalar? Yes. And acceleration is vector? Yes. So from here our correct answer is D. Now question number 3, velocity time graph for a particle is shown. Velocity versus time. In this graph we can understand that velocity is first positive, then it's 0, and later on it become minus, means negative. So which of the following graph shows this one? So as we know, displacement time graph, okay, the gradient is velocity. Okay, gradient is velocity. So velocity, we will find out the gradients of all the 4 graphs, and we will check which of the graphs showing that velocity is changing from positive to negative. So let's see the question number first. In question number first, we will make a gradient like this. So these are, till here it is positive, at this place it will be exactly parallel to this one, so it is going to be 0 here, the gradient is going to be 0, and later on it will become negative. So our answer is going to be option A. But see the option number B, here the graph is constant, means gradient is always 0, and in this gradient is always it's negative, it's negative, negative, it's no sorry, it's positive, it's positive, 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 positive. In this one gradient is always positive, and in this one gradient is positive, and then suddenly it become negative. But our answer is going gradually positive to 0, 0 to then negative. So from here our answer is only A, option A. Now see question number 4. Diagram shows a student during a parachute jump on a windy day. The vertical component of her velocity is 5 meter per second. This is vertical component, and the horizontal component of her velocity is 8 meter per second in the right direction. She descends at an angle of theta to be vertical to theta. Angle is from vertical, so from vertical is this angle is theta. So which row of table gives expression for magnitude and angle of students resultant velocity? So we have not to calculate the whole, but only we have to write the resultant magnitude. So as these are at 90 perpendicular, these vectors are perpendicular, so we can use this formula 8 whole square and 5 whole square. This is our resultant, this is our resultant, and for direction we can use tan theta. Tan theta is going to be 8 by 5. From here theta is going to be tan inverse 8 by 5. So resultant is this, and so from here our correct answer is C. Now come on question number 5. An object on moon falls a vertical distance of 0.32 meters from a rest. So U is 0, S is this, and time is equal to 0.63 seconds. Okay, which of the following expression gives acceleration due to gravity on the moon as moon in meter per second square? So we can use here a formula, S is equal to ut plus half a t square. As this is coming to down, we can say here that the displacement is negative. So minus of 0.32, and U is 0, so this quantity will be 0 and half, and this A is minus of G, that is 9.81, and T square. But actually we need to calculate this A. Okay, so we will remove this, and but the direction is in downward, so we will take it negative, and this will as t square. So this negative and this negative gets cancelled, and our A will be 2 times 0.32 upon 0.63 whole square. So from here C is right answer. Now question number 6. The graph shows how terminal velocity varies with mass for a small sphere of equal diameters falling through a viscous liquid. Falling Which of the following describe the gradient of the graph for a liquid greater viscosity? As we know, terminal velocity is inversely proportional to viscosity. So if we increase viscosity, terminal velocity will decrease. So from here, answer is going to be B, a smaller gradient. A person is pushing a trolley at a constant velocity. At a constant velocity, okay. A person is pushing a trolley at a constant velocity. Floor exerts force P on the person and person exerts a force Q on the trolley and trolley exerts, see, let me draw, floor exerts force P on the person. This is force P. Person exerts a force Q on trolley. Person exerts a force Q on trolley and trolley exerts a force R on the person. And total drag on the trolley is S. Okay, here. So which pair of force is Newton's third law? So this and this are repelling each other. This is so from here Q and R is Newton's third law pair. A wire breaks when a tensile force T is applied. A second wire is made up of same material, has twice diameter. Which of the following force is required to break the second wire? As we will increase diameter as twice, area will increase 4 times. So we will need 4 times tension. So from here A will be correct answer. A beam is balanced on two supported as shown. Beam 1 P and Q, and this is the center of mass, here W. A beam has a weight W and reaction force at the two supports P and Q. Which of the following statements about the magnitude of force is correct? Which of? This one or this one? So here P is greater than Q, Q is greater than W, and P is greater than, so W is greater than P, and so what we need, this is the total mass. So let's say this mass is M, so this is going to be mg. But these supports are not balancing the actual mass of this beam. This is supporting this much. This will feel less weight as compared to this. It will feel higher weight because it is closer to the center of mass and it is far to the center of mass. So from here we can say Q will feel larger force, so it will reaction force will also be larger, so Q will be larger than P. So from here answer is going to be C. C1 is correct answer. Which row of the table contains two units that are not equivalent? Which one? So joules per second is equivalent to watt, but this is Newton. Kg meter per second square, mass into acceleration is Newton, but this is not Newton second, but this is same as this, this is same as this. So from here we can say B is not equivalent in quantities. Now our section 1 means section A is completed. Now section B. Answer all questions in space provided. A slow moving asteroid A, this is moving slowly, let's say small v, was hit by a faster asteroid B, this is moving faster, was absorbed by asteroid A as shown in this. Okay, this is small, this is large, it is moving with small velocity, it is moving with higher velocity. They will collide, and after collision they combined, okay, and moving together. Let's say some v. So first question is A. State the principle of conservation of linear momentum. What is linear momentum? Linear momentum is momentum before the collision and after the collision will be equal if there is no external force. So total momentum before and after collision will be same if there is no external force acting on the colliding objects. See B question. Before collision, asteroid A has a velocity of 2.19 into 10⁻³ meter per second and momentum is given to us. Show that mass of asteroid A was about this much. So what we can use, as we know the formula of momentum, mass into velocity. So momentum is given to us a 1.8 into 10⁻27 kg meter per second into mass into velocity. From here we can calculate mass. So after dividing these two quantities, we will get our required mass of asteroid A. So from here we get mass of this, and now see it further in question second. Calculate velocity of asteroid after collision. Asteroid velocity after collision. So the mass of asteroid B is also given to us. Velocity of asteroid B is also given, and we have calculated mass of asteroid A and velocity was given. So what we can do here, we can conserve the momentum before the collision and after the collision. So before the collision, this was momentum A and this was the momentum of asteroid B, and this is the momentum of whole A and asteroid B. So after calculating these two, we will get 2.685 into 10⁻70 Newton second, and after calculating the two masses we will get this, and after dividing these two numbers we will get the combined velocity of asteroid after collision is 3.048 meter per second. So you can write the velocity of asteroids as this. Now a diagram shows a lift system for moving people ups and down a tall building. There is a counterweight to balance the weight of lift. An electric motor is used to raise or lower the lift. Okay, this is the electric motor, here the lift, and in this lift people are staying, standing, and this is the counterweight. So see, what is first question? Explain how counterweight affects the amount of work required for electric motor to raise the lift. So what we can write, there is electric transfer, there is energy transfer between counterweight and the lift. The total work on the lift cage is sum of work done by counterweight or gravity and by the motor. Means if this gravity will comes down, this counterweight will go up. From here we can say it will increase some kinetic and potential energy. So there is energy transfer between counterweight and the lift. Whatever the energy will decreases by this, by potential or by kinetic energy, we can add up the sum of the work done on the lift cage is sum of work done by counterweight and the gravity and by the motors. So we can use sum all the works done by counterweight, gravity and motor. Question number B. Electric motor rises the lift through a height of 40 meters in a time 30 seconds. Okay, shows that its output of electric motor is about 12 kW. Total mass of lift and people is about 2250 kg, and mass of counter weight is 1300 kg. So as we understand, the work done is equal to force and displacement. Energy of gravity is mgh, and power is work done divided by time. For counterweight, the gravitational potential is equal to mgh. So mass of counterweight is 13, g is 9.81 into 40 meters, because the electric motor rises up the height of this much 40 meters. So from here we get our potential energy as 5.01 101 into 10 raised to 5 joule, and for the lift, gravitational potential will be equal to mg delta h. Here the mass of combined lift and people is 2250 kg into gravity into 40. So from here we get 8.829, and the difference of these two potential energy is required energy. So energy required is this much. So after the energy required, this is our work done, and work done divided by time is going to be power. So power is 1.243 into 10 raised to 4 watt. The electric motor dissipates energy to the surrounding at the rate of 3600 watt. Determine the efficiency of electric motor. The efficiency is useful power output upon total power input. Okay, this is surrounding, so we'll add up. These are useful and this much is dissipated to the surrounding, so we will add all the power input power, and from there we get 0.775 efficiency. Okay, 0 to 1. Now question number 13. The Troy lane transfers a technique for crossing a deep valley. The photograph shows a climber crossing a river using this technique. The climber moves along a rope suspended from the bank on either side of the river. Okay, let's say this is here is the river flowing, and he wants to cross this river by this rope like this. So free body diagram of for the climber is shown below. The weight of the climber is 650 newton, and this is the rope, and it is making angle 46 degree with horizontal. So 46 we can take component of this tension. Shows that tension T in the rope is about this. So vertical component of tension is T cos we will make like T cos 76 degree, and this will also be T cos 76 degree. So 2 times T cos 76 degree is equal to 650 newton, and T is going to be 650 divided by 2 cos 76 degree. After using calculator we will get T as 1345 newton. Okay, so question number B. The rope has an unstretched length of 120 meter as shown below. Okay, the length of unstretched rope is 120 20 meters, but after the climber it will increase there will be some increase in length. So we need, okay, can determine the strain in rope while it is supporting the weight of the climber. If you ignore the weight of rope, so we can ignore the weight of rope. So new length of cord is 2 times, because if we will take, okay, so what you can, this is 60, and after taking what, you can take here sine theta. Okay, if we will take sine 76, so this will be 60, and if I'll make, this is A and this is B upon AB, so what will be your AB? AB will be 60 divided by sine 76. So sine 60 is sine divided by 6, so this plus this, so therefore 2 times 60 over sine 76 meter is equal to 123.67 meters. So what is the change in the length? So new length minus old length is 123.67 meters minus 120. The change in the length is 3.7 meters. Okay, so the strain will be equal to, okay, the change in length upon original length. Okay, so we will make here, no, it will not 0.7, it will be 3.7 meters, and after calculating we will get 0.03. So you can write here strain as 0.03. So question number 2. Rope has a cross-sectional area of 3.14 into 10 raised to minus 4 meters square. Determine the Young modulus of the rope material. Okay, so as we know, sigma is equal to F by force upon area. So from here we can calculate sigma, that is stress upon strain. So from here you can find out stress on the rope. So force is 1345 Newton upon area, and that will, after calculating, it will come up 4.28 megapascal, and the Young modulus is stress upon strain, that is sigma upon epsilon, is equal to 4.28 megapascal upon 0.031. After calculating, we will get our required quantity, Young modulus, as 1.38 into 10 raised to 8 Pascal. Number 15. A hollow brass cylinder with closed end is floating on the surface of water, and cylinder has a length of 4 centimeter and external diameter of 2.1 centimeter as shown. Okay, this is the brass material and the cylinder. Inside it air is filled, and here it is water. The length is 2.1 and the breadth, this is the breadth 4 centimeter, and this is the length 4 centimeter and the breadth is 2.1 centimeter, and 63% of volume of cylinder is submerged, means this much is submerged in this much part is into the water, and the cylinder contains negligible weight of air. The air trapped inside the cylinder has no weight. Explain why brass cylinder floats. Why it will float. Okay, we need to tell the reason why. There is an upthrust which is equal to the weight of water. Means water will make an equal upthrust as the weight of this brass cylinder. Okay, weight of the water displaced. The upthrust is equal to the weight of cylinder when it's partially submerged. Okay, when it is partially submerged, the weight of upthrust is equal to the weight of the cylinder. I hope you understood the reason why it will float, because the upthrust is going to equal to, will exactly match the weight, how much the weight it is. The density of water is given to us is 1.0 into 10 raised to 3 kg meter raised to minus 3. Show that the mass of the cylinder is about 9 into 10 raised to minus 3 kg. Volume of cylinder is pi r square L, and this is rho. Rho means density, and density is mass by volume. Mass by volume. Volume of cylinder is pi value we can substitute 3.14 into 10 raised to 1.05 into 10 raised to this. Okay, after calculating all the numerical values, we will get volume of cylinder as 1.39 into 10 raised to minus 5 meter cube. The volume submerged is 63%. So the volume submerged will be 0.63 into the volume of cylinder, and after calculating we will get as 8.76 into 10 raised to minus 6 meter cube. The mass of cylinder is the mass of water displaced. So the density into volume, this is the density of mass, and this is the density of volume displaced. Okay, water displaced. So this much is the mass of cylinder. Mass of cylinder is 8.67 into 10 raised to minus 3 kg. Question number 2, subpart 2, deduce whether any identical hollow cylinder made up of gold would also float. Assume that the volume of gold is the same as the volume of brass. Now if we change the brass volume cylinder as a gold, then what will happen? It will float or it will sink. The density of gold is 19.3 into 10 raised to 3 kg meter per second, and the density of brass is 8.7 into 10 raised to 3 kg meter cube. So volume of gold is equal to volume of brass. Why the volume of gold and volume of brass are equal? Because volume is given equal. See, volume of gold is, assume that volume of gold is same as the volume of brass. So from here we can calculate, as we calculated earlier, the mass of brass is 8.76 into 10 raised to minus 3 kg. We have calculated here. Okay, and divide this mass by the density of the brass. So from here we will calculate a volume of gold. So after calculating this, we get 1 into 10 raised to minus 6 meter cube mass of gold. Now the mass of gold is volume into density, and density is here, so this will be our mass of gold, that is after calculating mass into volume. So it will be 0.0193 kg, and the volume of water will be the mass displaced, okay, volume of water as the weight divided by volume. We will get weight divided by density of water, we will get the volume of water displaced. So here the required to float is 1.93, but okay, volume of water required this much, but we provided this here. See, here the volume of cylinder is this, because we assume that the volume of cylinder and volume of gold to be same. So but from here what we required to float volume of water required to float is needed this, and it is much higher to this, so it will sink, okay, it will not float, it will sink. This is another question. The photograph shows a toy pinball machine. The launcher is pulled back, compressing a spring. The spring obeys Hooke's law. When the launcher is released, the spring returns to its original length and a small ball is launched horizontally into the machine. Okay, horizontally into the machine. So see, this is our ball, this is the spring which is compressed, and this is the launcher. So when the launcher is pulled back, the spring is compressed by 5 centimeter. When the spring is released, the ball is released at the speed of 8 meter per second. Show that kinetic energy of ball after launching is about 4 into 10 raised to minus 3 joules. Mass of ball is 12 grams. So what is the formula of kinetic energy? That is half mv square. Half, and mass should be in kg, so we will multiply it 10 raised to minus 3, and velocity should be in meter per second. So again we will multiply 10 raised to minus 2. So after calculating all these, we get kinetic energy as 3.84 into 10 raised to minus 5, which is nearly 4 into 10 raised to minus 5 joules. Okay, now question B, determine the force on the ball when the spring is released. How much the force, and determine the force on the ball when the spring is released. So change in kinetic energy is half of the work done. Force in displacement is work done. Okay, we know the formula, that is the change in total energy. The change in total energy, this is not kinetic energy, this is change in total energy, is half of the work done. F force into displacement, and that is kinetic energy also here. So F force is equal to kinetic energy times 2 upon over the delta x, and that is 0.025 meters. 0.025 meters. So the kinetic energy is 3 point this into 2 divides by 0.025 meter. After calculating, we will get force as 1.54 into 10 raised to 3 newtons. See, what I think there is some problem. I think this is half force into displacement, and displacement is 0. Let me solve it here. That force is equal to not force is equal to, this is kinetic energy is equal to half time force into the change in displacement, that is 5 centimeter, and that is 0.5 meters. So it will be now kinetic energy, and it will divide, so 0.025 meters. So now the F will be equal to kinetic energy divides this. Okay, this will not come here. Okay, this is our one step. So now we will divide kinetic energy with this. This is not going to help, so now it is going to be match your answer. Now it will go and match your answer. Let me calculate. Okay, 3.84 into divides by 0.25, that is 153. Okay, yes, it will match. It will match your answer. Okay, so see further. Determine the stiffness of the spring. We also know the formula in spring force, that force is equal to K time into X, and that is stiffness of the spring. So the force is 1.54 into 10 to minus 3 Newton, and this is K, and the displacement is 0.05 meters. So after calculating force divided by 0.05 meter, we will get this stiffness constant, that is 0.031 meter 1 Newton per meter. Okay, spring returns to its original length. After stretching, the spring will returns to its original position. Sketch a graph on the axis below to show how the velocity of ball varies with length of the spring. As original spring returns to its original length, that is, the original length of the spring is L meter. Okay, let's say L, and when we compressed it with minus 0.05, it is the length when it is compressed, means when we will compress it by 0.05 meter, then at that moment the ball has zero velocity, and later on when you will release it, it will come on to its original length, and here ball will attain 8 meter per second velocity. So the graph will be like this, and the initially the gradient or gradient of this graph is decreasing. Okay, decreasing. So now question number 17. A small sphere is moving horizontally through a viscous liquid. Okay, a small sphere is moving vertically through a viscous liquid. A Stokes law can be used to calculate drag force on an object. State the condition that must apply for Stokes law to be valid. Okay, हमें what is asked in this question, conditions that apply for Stokes law. There must be a sphere object having low speed. First, there must be a sphere object and having low speed. It should have low speed. After that, when it fulfills these two conditions, so there is a force constant 2.3 into 10 to minus 5 Newton acting horizontally on this sphere. The diameter of sphere is this, the viscosity of liquid is this much. At one instant, the speed of sphere is 5.2 into 10 to minus 3 meter per second. Calculate the resultant horizontal force on the sphere. Okay, we need to calculate resultant force, that is, drag force is, let's say this is the container or a tube. In this tube, viscous liquid is filled. Okay, a ball is moving down with some velocity, but there is a drag force in opposite direction. If it is moving downward, then the drag force will be in upward. If it is moving upward, drag force will be in downward. It is always opposing force. So that will be 6 pi eta r. Okay, 6 pi eta rv. This will be drag force. So 6 pi eta rv, we can put the values of these constant. So after putting the values, what we get, drag force as 1.6 into 10 raised to 5 Newton, and a constant force this much is acting horizontally. Let's say this is the force acting on this, 2.3 into 10 raised to minus 5 Newton per second. Okay, this much force is acting on it. So the resultant force will be this force minus the drag force, this force minus drag force. So it is 0.7 into 10 raised to 5 Newton. Okay, this is our resultant force on this sphere. Calculate maximum speed of the sphere in horizontal direction. Now we have to calculate the maximum speed. So for that, force is equal to this. Maximum speed means that drag force should be equal to the force applied. This is velocity, not volume. Okay, this is velocity, not volume. Here, see, this is velocity, not volume. So velocity value is 5.2 into 10 raised to minus 3 meter per second. So at the moment when maximum velocity means whatever the force we applied is exactly equal to the drag force. So at that moment the maximum velocity can exist. So we can substitute these two, and after calculating we will get maximum velocity as 7.64 into 10 raised to minus 3 meter per second. Okay, or meter second inverse. Question C. A large diameter sphere in the same liquid is acted upon by the same constant force as in B. The liquid is at a lower temperature. Explain the effect these changes have on the maximum speed of these spheres. Now we have to write down the theory. How? Explain effect these can have on the maximum speed. Okay, first, a larger diameter of sphere, same liquid upon the same constant force. Liquid, it is at lower temperature. Now the liquid is at lower temperature. Drag force formula is this: larger diameter radius gives larger drag force. Means if the diameter has larger, the drag force will be larger. If the more viscous liquid can produce more drag force. So at a given speed, the direction a larger diameter gives a lower speed. For the same constant force, viscosity depends on the temperature. At lower temperature, viscosity is greater. Okay, write down this is the meaning. Viscosity depends on temperature. At lower temperature, viscosity is greater. At lower temperature, viscosity is greater, and greater viscosity gives larger drag force. Greater viscosity will give larger drag force. Greater viscosity gives lower speed for the same constant force. Okay, this is the explanation. Now question number 18. A stunt motorcyclist wants to jump across a river. This is the river that a biker wants to jump like this, because there is no pole to way, there is no way to cross. Okay, by making a walk cross this river. This is the only way we can jump like this. At high speed we can jump only, stuntman. So a stuntman, the diagram shows the motorcyclist driving off the ramp at the edge of the river. Okay, here, from here, the ramp is at an angle of 25°. The horizontal, the height of end of the ramp is 3 meters, and the width of the river is 100 meters. The initial speed of the motorcyclist is 35. Now, first question is about calculate the horizontal and vertical component of motorcyclist initially as it leaves the ramp. So what we can do, if this is 25, this will also be a 25, and now you can make two components. One is parallel to river and one is perpendicular to river. So this will be Vx is equal to 35 into cos 25, that is 31.7 meter per second or inverse second, and Vy, that is vertical one, 35 into sine 25, that is 15.8 meter second inverse. Okay, horizontal component and vertical component we have calculated. Deduce whether the driver lands on the other side of the river. We have to check whether it will land or not, or it will fall. Before it land, it will fall into the river. Okay, the effects of air resistance can be ignored. We can surely ignore the effects of air resistance. So as it moves in x direction, what we can say, the distance should be w ux into t. So s is equal to ux t, and time to travel 100 meter is, that is 100 meters divided by 31.7 meter per second, because in the x direction we can calculate the time to cover the 100 meter distance. Okay, so from here we can calculate time. We know the distance is 100 meter and the x direction speed, that is 31.7 meter per second. So after dividing 100 by 31.7, we will get 3.15 seconds as a time to travel. Okay, this much time is required to travel this. And now we will check the vertical distance and time. Okay, in 3.15, how much it will cover in vertical distance. Okay, vertical displacement will be how much, because we have 3 meter high ramp. Okay, 3 meter high. So the vertical displacement is uyt minus half gt square. Okay, gt square. So you can write here initial speed in y direction is 15.8 into time is 3.15 minus half 9.81 into 3.15 whole square. After calculating, what we get, minus of, okay, if you're not clear, minus of 2.112. Minus is because it is, the displacement is a vector quantity and it is showing that in downward direction. Okay, in downward direction. In 3.15 minute it will travel in vertical displacement this much, and still we have to, it will cross 100 meter, and when it will jump, it will like this, it will cross this river in 3.15 seconds. So see here, so the rider lands on other side of the river. Explain how air resistance would affect the jump. Now air resists the motion, like a retardation, like a friction. Friction opposes the motion of an object. Similarly, air resistance also opposes the motorcyclist in opposite direction. Okay, motion of air resists the motion of motorcyclist in opposite direction. If it will decrease the speed of motorcyclist in horizontal direction and it will de-accelerate also, the maximum height reaches by the motorcyclist will also reduce.